Welcome back to Probability and Statistics. In this video, we're going to talk about analyzing graphs. And the first thing we're going to do is talk about the appropriateness of different graphs that we have. Alright. First one is called a time series graph. It's referring to a line graph that is used to display a variable whose value changes over time. Okay, time series graph. Another one is called a cross-sectional graph. It will display information collected at only one point in time. So I will begin to kind of show you this. For example, so this is a picture I got from the textbook. All right, appropriateness of the graph. Gotta have a title. Okay, gotta have a title for the bars. Gotta have a source. For example. All right. Time series graph, for example. Okay, time series graph. Line graph that used to display variable, okay, whose value changes over time. So as time goes on, it changes over time. So again, I got title, I got my percentage for the y-axis that I label. I also label my x-axis, okay, using month as my category. Time series graph. Variable changes over time. An example of a cross-sectional graph. And this one is called a pictograph. So again, what's a cross-sectional graph? It displays information collected at one point in time. So this pictograph, using pictures for my graph. Alright. I want to show you the difference between a correct graph versus an incorrect graph. And if you look at it, okay, the correct graph display as the year goes on, okay, the average monthly housing cost for students goes up. Now, this one is a little bit more inappropriate, okay, because when the average housing price goes up, they actually display a bigger house. Okay, so that's a little bit inappropriate. The size of the house should be the same, but the height of the house is actually need to reflect on what the data shows. Okay, so be careful. Incorrect pictograph can actually persuade our view. All right, this is the U.S. federal hourly minimum wage. Okay, I got my source right here. Alright. I think I'm missing a picture or something like that. Oh, excuse me. Yeah, I sure did. This is a cross-sectional study. Alright, cross-sectional graph right here. Display information collected at one point in time. Okay, everything is titled. This is another example of pictograph, using picture to display. Okay, everything is appropriate. Okay, same number of people, same size of these little pictures. Okay, all right, this is a line graph. All right, everything's labeled, looking good. Now there's a little bit problem with this one. Notice that the date on the x-axis is very inconsistent. October, 38, 39, then the next one is 45. Okay, we're jumping a year here, and then this is 5 more years later, 5 more years later, 5 more than 2 years later. Then the dates start to change as well. So the inconsistency of my labeling here on the x-axis kind of you can actually throw your it doesn't throw the number off, it just throw your perception off, okay, what the graph is trying to show. Alright, inconsistent. Okay, gotta be very, very careful about the graphs, the display of data that you're looking at. Okay, alright, now in this particular video, what I really want to talk about is the shapes of graph. Okay, I will begin to use this word a lot later on the semester. It's what we so-call the normal distribution. Okay, the word normal distribution means it has a bell curve shape. All right, if my histogram shows a bell curve shape, okay, that means your distribution is symmetric. All right, bell curve shape, that means it's a symmetric. All right, uniform distribution, the picture of uniform distribution. Okay, uniform means it's all about the same, so every one of these bar graphs is almost the same height, so we can say our entire distribution, okay, is uniform. Alright, if my histogram is skewed to the right, the way how you remember this is where the tail is. If the tail is on the right, okay, that will be skewed to the right. That means the majority of the data is concentrated on the left side, okay, rather than in the center. Concentration on the center is called symmetric or bell curve shape. Skewed to the left means that means the tail is on the left side. Okay, so the data is concentrated on the right hand side. So if we're using grades of tests in this class, for example, what you want is, of course, skewed to the left, so your grades will be concentrated towards the right hand side, which is higher grade. You definitely don't want to be like skewed to the right where your grades are on the lower end. All right, you definitely don't want your symmetric either for your grades. That means everybody's making about what, right there in the middle. Okay, you want your majority of grades concentrate on the right hand side for your grades. All right, so for example of the shapes of the distribution, the symmetric, the bell curve shape is what we will end up using a lot, okay, in other chapter for rest of the semester. Actually, this is the picture that we will talk about the most. All right, that will conclude this lecture video. Thank you for watching.